The lesson topic for this video is adding and subtracting polynomials, part 2. So all we're going to do in this video is two examples, one with addition and one with subtraction, and they're just a little bit more complicated than lesson 8.2. And the reason for that is in our previous lesson on adding and subtracting polynomials, I had the same terms in this set of parentheses as I did in this set of parentheses, the same like terms. So for example, this was a 6x squared right here, then this term here would have been a 6x squared an x squared term, I should say, here. Maybe it was negative 2x squared, but they matched. They were like terms. As you can see in this example, that is not the case. So what happens if we are asked to add polynomials when we've got an x squared and an x to the fifth, and then in the second term, or expression, I should say, we have a constant and an x squared and an x to the fourth and an x to the fifth term? Well, we do the same thing, but we just need to be extra careful. Okay, so for this one, I'm going to use different colors and do some underlining and circling. In the second example with subtraction, I'm going to show the stacking method again. So let's start by looking at our first expression. Again, we have 6x squared plus 2x minus 9x to the fifth. And I can go in any order I want when I'm collecting or combining like terms. So I'm going to always start with my first term. So I have a 6x squared. The question is, do I have another x squared term somewhere? Well, I do right here. So I have 6x squared and I have negative 1x squared. So together, that will give me 5x squared. Next, I'll use blue, and I have a positive 2x. In my second expression over here, I do not have an x term, so I will not be combining this positive 2x with anything throughout the problem. So I'm just going to write plus 2x. Then I have minus 9x to the fifth. Over here, I have a plus x to the fifth, and therefore I know, again, this is a 1, so I have negative 9x to the fifth plus 1x to the fifth. Together, that gives me negative 8x to the fifth. You're leaving the variable part and adding the negative 9 and the positive 1. Now, I don't have any more terms in this expression, but I do have additional terms in this expression, so I'm going to keep on going and keep on adding the pieces I'm missing. So I have a minus 2 that I need to include here, minus 2, and then I have the plus 3x to the fourth as well. So plus 3x to the fourth. Now, again, this was all possible the way we just did it because this is addition, not subtraction. Otherwise, we would have had to do something first. And there was no number in front of our parentheses, or we would have had to like distribute that into our parentheses, but it's just all adding terms. All right, so now we're not quite done. Okay, remember, at this point, we need to write this in standard form. And to do so, we're just going to start with our variable that has the largest exponent. So that's right there. That 5 is our largest exponent on a variable. So we're going to write, don't forget, negative 8x to the fifth. Don't forget that negative sign in front. Our next lowest is this 4 right here. So we're going to have plus 3x to the fourth. Then we have over here a power of 2. So we've got a positive 5x squared, so plus 5x squared. We have a term with just an x, so that means kind of like x to the, remember what goes here? The 1 right there, x to the first. So we're just going to write plus 2x. And lastly, we have our constant, which will always go at the end. So this is our final answer right there. Notice that I have no more like terms. I didn't miss anything. They're all unlike terms, so they cannot be combined anymore at this point. Okay, and the second example we're doing in this lesson is a subtraction problem. Always pay attention to what symbol is in there to know what we're doing. So we're going to take the first expression, we're going to subtract the second expression. Please notice this is a 3, got a little messy there. Okay. I'm going to use the stacking method for this problem. And when I use a stacking method, what's kind of nice about this method is we're going to start by putting it in standard form first, And then you don't have to do that at the end like we did in the previous example. Again, use whatever method you prefer. What I'm going to do is I'm going to start with my first expression, and I'm going to start with the term that I would need to put in the front, and that would be negative 3m to the fourth, because that is my leading term, because it has the highest exponent here, right, 4. Notice there are no m to the fifths or sixths in the entire problem. Now, when I go and write my next terms, notice the next term I have in this expression is m squared. So I don't have an m to the third right here, but notice I do have an m to the third over here. So when I do my stacking here, I'm going to actually leave a space for that m to the third. We could put it in as plus 0 m to the third if we wanted to, and then plus 10m squared, and then plus 8m, and then we don't have a constant at the end either. We could put plus 0, we could just leave it for now. Again, this term I put here, I don't have any m to the thirds, but I know I have some m to the thirds, so I'm going to put a 0 m to the third. I have 10m squared, and I have 8m as well. Now, I'm going to subtract minus, right, my other expression. Now, I'm not going to rewrite it other than putting it in the right order right now, but this is subtraction. We're going to come back to this. So I have the highest exponent I have is m to the third. So I have 11m to the third. Now, what I'm going to do with that is I'm going to put it under my other m to the thirds right here, right? So plus 11m to the third. I've got a 3m squared. So I'm going to put that over here, 3m squared. And then, and it's positive right now. Okay, we are not dealing with that subtraction sign yet. And then we have a minus 7. Now notice that doesn't have any m with it, so that's my constant. So I have minus 7 over here, but don't put that directly under the m term because we don't have any m's. So if you're more comfortable putting plus 0m in here, we can, right? Just like we did here. Maybe I should have put that in a different color. Okay, so those are the terms we didn't have, but we leave some, I guess I would call it a space holder. There's the word I'm looking for, a placeholder for that space in there so that we line everything up nicely. So that took a while to explain and walk through, but I think you would probably get the gist. So here's my m to the fourth terms, my m to the third terms, my m squared terms, my m terms, and my constants. Now I'm going to subtract my expressions. So what I'm going to do is I'm going to make this easier on myself by changing it to addition. So if I change, let's use purple here. If I change this to addition, that's fine as long as I change the sign of every term in our second expression. We don't have to change the terms on the first one. So I'm going to change this plus sign right here to a minus or negative. I'm going to change this plus right here to a minus. And I'm going to change, it doesn't really matter here actually, right? Because we're not going to add or subtract anything. And then this minus right here, I'm going to make a plus. Okay, so I changed every term. And now I can finally add my expressions. So negative 3m to the fourth. Then we have 0m to the third minus 11m to the third, so minus 11m to the third. Then we have positive 10m squared minus 3m squared, so that's plus 7m squared. And then we have plus 8m minus 0m or plus 0m. It doesn't matter because you're not adding or subtracting any when it's 0, so just plus 8m. And lastly, we have plus 7. So again, I don't have any like terms anymore in this expression. I have an m to the fourth, m to the third, m squared, m, and constant term in the right order for standard form, and we are done.